if alpha beta be real and z be a complex number such that z square plus alpha z plus beta is equal to 0 has two distinct roots on the line real part of z equal to 1, then which is a necessary condition for beta? So let us do this question. We have been given that the real part of the complex number, that is real part of our z, lies on x-axis. You know this thing? And the imaginary part will be lying on y-axis. Consider that z1 and z2 are the roots of the given quadratic equation, that is z square plus alpha z plus beta equal to 0. Now the question says that roots lie on this thing, that real part of z will be equal to 1. So that gives us the indication that the real part of both the roots will be 1. So z1 will be of the form 1 plus iota y1 and z2 will be of the form 1 plus iota y2. Now as we know that in a quadratic equation the sum of roots will be equal to z1 plus z2 equal to minus alpha, and that will be equal to 1 plus iota y plus 1 plus, it is 1 plus iota y1 plus 1 plus iota y2 equal to minus alpha, and that will give 2 plus iota y1 plus y2 equal to minus alpha. But as mentioned that alpha is a real quantity, so we should have its imaginary part should be equal to 0. That will say that y1 plus y2 should be equal to 0. That gives us y1 equal to minus y2. Now we can say that z1 times z2 will be equal to beta, because whenever we have quadratic equation of form ax square plus bx plus c equal to 0, and if alpha beta are the roots, then alpha times beta, that is the product of roots, equal to c by a, that is the constant term, divided by the coefficient of x square. So that will be 1 plus iota y1 times 1 minus iota y1, because y2 was what? y2 is equal to minus of y1, and that is equals to beta. On expansion we will be getting 1 plus y1 square is equal to beta. Now we can see that as y1 square is present here, and it can be only positive quantity, that is greater than 0. So 1 plus y1 square will be greater than 1 plus 0, that is 1, and 1 plus y1 square is nothing but beta. So we can say that beta should be greater than 1, which can be written in interval notation as beta belongs to 1 to infinity. So let us see which was the correct option. That is the C option, that says that beta belongs to 1 to infinity.